Hello, I'm JW, and in this video, circuit breakers. Here's an example of a Crabtree one, but they're all pretty much the same. And these devices are there for two reasons. They're to disconnect the supply in the event of an overload or in the event of a short circuit. Now, I've chosen these particular Crabtree ones to look at because these came out of a consumer unit which suffered some water damage. It actually leaked in from above. And I've actually got four of these, two of which stopped working, obviously due to the water leaking in, and the other two did not. So it might be interesting to see the differences inside and what has actually failed. And this isn't a particular problem with these circuit breakers themselves, it's just the fact that they're not designed, of course, to have water leaking into them. The ones in question, of course, have been replaced, the leak was repaired, and of course new circuit breakers were installed. So I've already taken the opportunity to drill out some of the rivets on these, so we should be able to open them up and have a look inside. Now, these are fairly ordinary circuit breakers, so these are Crabtree branded, but again, they're all going to be pretty much the same design. And these ones have the plug-in arrangements on the back. Most of the others actually have a screw terminal at the bottom. These just have that sort of pre-made piece which plugs into the corresponding part in the consumer unit. And they've got the usual terminal on the top there for the wires going to the circuit. And these are just single pole devices. The power will be connected in at the bottom, so you'll normally fire a screw there, or in the case of this one, the tab on the back, through the mechanism inside, and then your outgoing circuit will be connected at the top here. And this particular one is a 6 amp device, so typically that would be used for a lighting circuit. And there's another 6 amp one here. This 40 amp one was actually for a cooker circuit, and then there's another 6 amp one over there, which again was for another lighting circuit. Now, these things, of course, have a switch inside. These are all on the on position, and obviously in the off position it just disconnects the two terminals so that the circuit is no longer connected to the power. Now, as I said earlier, these ones actually came out of an installation which had suffered some water damage. The consumer unit was located high up on a ceiling, and the room above, in the floor above, was actually a bathroom, and there was a leak there of water, and water leaked down into the consumer unit. And as you can possibly see on the top here, there's quite a bit of corrosion in top of some of these, and the fault was only noticed when the circuit stopped working, and of course then the water leak was repaired, and obviously the circuit breakers were replaced with new ones. So some of these do not actually work, and some of them do, and of course they're all replaced, obviously because they'd all been subjected to the water going in there. Now, I have already drilled out some of the rivets here. These are basically with 4 rivets on the side here. And they just go through to the back. Now, this is another one of these devices which isn't really supposed to be opened, or certainly not designed for it, but nevertheless we're going to have a go inside anyway. So hopefully we can just press these rivets through, and hopefully we can open the device and see what's inside. Okay. So here inside, and so this other half is just a plastic moulding, so all the actual mechanism is in this half, and so just remove that piece and just turn this so then we can have a closer look at that. Right, here's inside the device, and the incoming connection is at the bottom here. This particular one has a sort of plug-in tab there which comes via the metal pieces here. Most types actually have a hole in the bottom here where a prong or wire would go in, and then there's a screw terminal kind of arrangement here, but in any case the power comes in at the bottom. And the contact is actually here, shown in the open position here, and it's between here and this movable piece here. So if I just move the switch there, you can see that will now close. So that's the actual switching part of the device. So assuming it's in the closed position, we'll come across to the hooked piece there, and it's actually connected to this piece of braid on the back there, which is not terribly easy to see. But that comes across onto the braid there, and then you've got a thinner wire there which forms part of this coil around this movable piece in the middle here. And this is basically a solenoid, so that when that's magnetised, this pin will move forward. And of course continues via all the wire there, and it comes out at the top here on another sort of braided connection piece there. Let's put that back in. And the braid actually connects to this movable piece of metal here, and this is a bimetallic strip of the type also used in thermostats, and current continues via this strip here, and then comes back via the terminal and of course out to the circuit wiring that you have. And the screw here is just used to tighten up and pull onto the wire so it's secured in position. Now these things have got two tripping mechanisms, and the first one of which is this coil here. And essentially when the device is in the on position, just place it there, of course current is flowing through this all the time, and in the event of a short circuit, the current that flows here will be extremely large, typically in the order of a few hundred or even several thousand amps, depending on the characteristics of the supply. This will create a magnetic field here, and it will move the pin there, and in this case it will push upwards, and on pushing upwards onto this piece here, it will cause the device to trip, and of course open the contacts at the other side there. So let's try and show that again. So contact closed, and when this is pulled up, springs open, and of course opens the contacts, disconnecting the supply. Now the other tripping part here is this strip, and this is a bimetallic strip, similar to the type also used in thermostats, and as the current passes through here, it will cause the strip to heat up. And because it's made of two dissimilar metals, one side of it will expand at a different rate to the other. This will cause the strip to bend, and as it bends, of course, it will pull on this little lever here. And if it heats up enough, and of course bends far enough, then it will cause the device to trip and switch off. And of course this is selected as depending on the rating of the device, so that if the current exceeds a predefined level, then of course that will disconnect the device. And this is the part which would typically react to smaller types of overload. So say for example on the 6 amp circuit breaker we have here, if say 10 amps was passed through it, and of course that would slowly heat up and cause the device to trip. Unlike the magnetic part, this is going to take some time to actually react, simply the fact that it has to actually heat and of course bend away. So that could be many seconds, or in some cases even a couple of minutes, before it actually heated enough to trip the device. Whereas of course the magnetic part is going to be pretty much an instant thing, as soon as that magnetic field reaches a predefined level, and of course it will trip the device pretty much straight away. Now this may be a bit difficult to see, but this is the 6 amp circuit breaker here, and this is the same component from the 40 amp variety. And as you can see, the strip is somewhat thicker, hence would obviously heat up more slowly before actually tripping. And of course that's exactly what you would expect. And in regards to the magnetic part, again, this is the 6 amp one here, and if you look at the 40 amp one adjacent, so the main differences are that there's far fewer turns on this one, and the wire of course is much larger to handle the obviously larger current, and of course fewer turns would mean a considerably higher current would be required to create the same magnetic field, and of course cause the plunger inside to move and trip the device. Now the other components in here are this central section here, made out of actual individual plates of copper or some other metal material, and the purpose of this is so that when the switch here opens, there's always going to be a spark or an arc between the two sides of the contact, and the size of that depends on the load that's being switched. But bearing in mind if this was disconnecting on a short circuit fault, there's going to be a lot of energy involved here, and the purpose of these is to dissipate the energy from that arc and of course prevent it from exploding and destroying the device. So the bottom contact here is actually in this position there, and as you see it extends all the way up here, and it actually goes all the way up to the top on this side. And the other contact here has a corresponding piece of metal, and that's actually on this side here, and that actually goes underneath and behind here and comes up the back here and actually connects up to the top over here. And all of these plates, although they're metallic, they're not actually electrically connected together, so between the two sides of the contact, as it were, which are simply extended from here and here, you've got a number of these individual metal plates. So if the arc starts here, the shape of these will cause the arc to travel along these two pieces of metal, thereby making it considerably wider. That in itself is obviously likely to cause it to break. And if it hasn't broken by that time, when it gets to these metal plates, these will actually serve to divide the arc into a number of very small little sections, each one of which of course is not going to be capable of sustaining any kind of arc for any length of time, and so it will be extinguished. And the fact that these are made of metal, it will absorb a fair amount of the energy as heat from the arc, and again help to dissipate that completely. And so on the top here we've just got this material which simply holds the various plates together, and the whole thing, as I say, is not actually fixed in there. It's purely a sort of a pressed fit, and if we can just sort of ease it out of there. As you can see, all the plates are essentially separated. See through the bottom there, and just held in position by these pieces of insulating material on either side. And there you can see a bit more clearly the extension of the bottom contact, which of course comes along again right up to the top. And on this side, this is the other side of the contact, but again it's this which is also connected to that side. And again that goes all the way to the top there, and it actually extends underneath the trip mechanism here. As you see, that actually goes up behind here, and then again connects into the top over there. There's actually an insulating sheet there which has fell out a moment ago, but although that's connected there, there's no actual connection between the two sides, as all of these plates are of course totally separate, and their whole purpose there is to say break the arc into a number of very small arcs, and therefore dissipate it and prevent it from destroying the device. And the other thing to note here is they've got this piece of material here which is actually a white ceramic, and that's to prevent the arc from melting a hole in the side of the plastic casing. There's actually another piece which goes over the top, so that fits into the other side of the case there. So any arc that's in here will be contained on both sides by this hard ceramic, and again by the metal on the bottom here, and of course on the top by the individual metal plates above, which of course absorb and dissipate the energy. So that's what's inside a fairly typical circuit breaker, and as you can see there is actually quite a lot of stuff in there, so hence they're surprisingly cheap for what they actually are. Now some of these have been made as counterfeit products of course by certain illegal factories, and typically these don't have any of this stuff inside at all. They just simply have the terminals and a bit of wire linking the two together. Of course such a device would be extremely dangerous because of course it wouldn't switch off in the event of any kind of fault, but nevertheless those things have been seen, and generally you can tell because when you pick them up there's no weight inside at all, and of course all of this metal here weighs a certain amount. But of course that's easily avoided by buying these from a reputable supplier, not eBay or some other dubious source. Now this was one of the ones which actually stopped working in the installation, so let's have a quick look inside, but it doesn't actually look particularly damaged at all, so you can only assume that a bit of